No, I'm live. I think. Guys, let me know what's going on. Hey, Asir. I think I'm live. So it's a new software I'm using. It's called StreamYard. So let me know the sound and stuff. So I'm not really sure how everything works. Cool. Guys, let me know what's going on. Okay, Gary, can you hear me on the phone? That's cool. How are you guys doing? So this is going to be like a learning thing for all of us. Let's see how I share my screen. Let's see what happens. I've got two screens. Like this. Cool, I've got Altium and KiCad open. Spaghetti code I see is in. So at the bottom here, I can see people in the queue. So I see spaghetti code here. I just want to see how to. So I can share application. Cool. So I can make that bigger. Yeah, okay, cool. So I can. So that works quite nice. Like I said, guys, just bear with me today. I think I've got KiCad also open. Where's my KiCad? Yeah, cool. Spaghetti code, you can just chat in the comments. Are you ready to come on to chat a bit? I know you wanted to put some radio frequency help. I don't think I'm the right guy for that, but let's see what happens. Private chat. Okay, cool. There's a private chat as well. Yeah, that's sweet. Okay, cool. I'm just going to carry on with some PHP design until people want to join. Gives me time to test the program. Cool. At least I know the link works. It seems like I can only share if the thing is active. Yeah, so there I can share. That's pretty cool. KP. I actually finished the macro keyboard yesterday, but that's on my other laptop now. KP, if you want to come on to chat, just let me know in the chat or in the private chat, and then I can push you to the stream. Yeah, so when you're ready. Just start a new project. New project, need to do it. That's pretty cool. Cool, I'm going to push KP to the stream and let's see what happens. Excited. Hey, can you hear me?
Yeah, I can hear you. How are you?
Good, thanks, and you?
I'm good.
How can I help you? Or try to help you?
Well, I just wanted to check on
I'm
how,
just going to put this on.
right. So wanted to check on what would be the considerations when we move to multi-layer boards, maybe 4-layer, 6 layers, 8 layers. How do we consider placement of the components, and where do we put the ground planes and the power planes?
So what's the main reason you want to go to a 4-layer board? Is it because of the space requirements, or is it just something you want to try?
Well, both. I wanted to try more layered boards, maybe to give a try to reduce the EMI
Yeah,
interferences and things like that. So
yeah.
that's where the main concerns.
So that normally is then your best point. So it's always a preference. So you'll always have a VCC plane and a ground plane, or the other way around in the middle. You can have it at the top, but I don't prefer that because when you start routing and you make a mistake on the PCB, to fix it when you receive the PCB is a bit difficult. So the generic for 4 layers is always signal on top, and then a ground plane, power plane, and then signal at the bottom. That's for the 4-layer board. But I would not go. Yeah, it depends how compact you want to make it. Is this for work or is it just for hobbiness?
Just hobby,
Just
no
hobby.
work.
Yeah, no, it's fine because yeah, I've made one 6-layer board in my life. After that, when I do it myself, it's no more than 4. But it's only for EMC. So if you have high fast signals and things like that, it helps a lot because then you don't have to cut your ground planes. Because when you have your ground plane and you want to cut it, that's not good for the EMC.
Yeah,
That's
exactly.
what I'm trying to say.
Yeah, that's what I read. I was reading through a lot of blogs
Yeah.
from different people, and most of them suggest the same thing, as in do not cut your ground plane a lot, keep your signals consistent and things like that. So I thought, yeah, maybe I'll have to give it a shot about maybe a 4-layer board and see how the EMI works on that kind of board and things like that.
What are you planning to build?
Well, I'm trying to work something around the home automation
Yeah.
pieces. So wanted to try a few things like the switches or the fan speed controller, dimmer, all of those. So wanted to
Okay.
try and build something of my own.
Yeah. But that's not really fast signal, so I don't think you have to worry too much. It'd be nice to do, but just remember 4-layer boards are also more expensive. So you pay for that. It's not the same
Yeah.
price. So, but it's a good thing to test. But then for EMC, I don't know if you have a radio because you can actually use like a ham radio and just start transmitting signals, and that can interfere a lot as well. So that's a nice way to test. Are you interested in learning about this EMI, EMC? Because I've got a folder on Google Drive that I can share. It's from a guy called Lee Ritchie, and he's got like all these documents about 10 gigahertz signals, how to route it, how to do it, and the reasons why you do everything. So I can share that
That
on
would
the
be
link
excellent.
now.
I'd like to, yeah. I would like to read through it and see how it pans out. Maybe I can, then feed you back as to did that work really or not, or what did I do in the end.
Yeah, it's always nice to. I'm going to share the link now. Share. Can view copy link. I'm going to paste it in the comments now. Then you can just have a look. Let me know if it works. So I went on a course, many years ago. A guy called Lee Ritchie, and if you go on the Altium website, you'll actually see him quite a lot. And he speaks about this EMI, EMC things. So therapies and stuff. He's heavily against it. It's quite interesting. But there's a lot of documentations you're going to go through there. So I shared it now. Is there any other questions?
No, nothing really.
Do you have KiCad or Altium installed?
Sorry, come back again.
Do you have KiCad or Altium installed, or have you played around with it before?
Yeah, I generally use the Eagle as my CAD. I felt KiCad a bit more difficult to handle, and
Oh
Altium
wow.
is too expensive to
Of course.
buy the version.
Yeah. So Eagle's easier than KiCad. I should try Eagle then.
Uh, yeah, I felt Eagle to be a bit easier than KiCad.
Okay. Cool, man. Yeah, just let me know again if you have any other questions. I'll go to Spaghetti
Of course.
Code now. I'm a bit worried about him because he wants to ask high frequency questions that I don't know the answers. So let's see what happens. Thanks, KP. KP, what's your name? If
Kunjal.
Good job. Okay, not Kevin Peterson.
Yeah.
Okay.
No,
Thanks.
not even
We'll,
close.
we'll, we'll chat later. Thanks. Bye.
All right, cool.
Hey,
Hey man, hey.
I think you're going to give me answers, man.
So actually, my actual name is Yasser Sun.
Yeah.
I just named it as it's just no one. So basically, I have two basic questions around designing CAD designs. One is relative to KiCad, and one is generally about RF systems.
Yeah.
So I know. It's okay. So the first question about KiCad is like when we generate a bomb, it with having DNP or do not populate capacitor inductors, it generally comes out just value as DNP.
Yeah.
But when you see in Altium, I also use Altium for quite some time, but as it is really expensive, so
No, that's
uh,
cool.
so you know in Altium you can make variants around
Yes. With the
having
X's and stuff.
DNPs. Exactly. I need to actually know how can you make variants in KiCad, and how can you exclude DNPs and from like variant one, variant actual design, or variant
Yeah.
DNP variant, something
To be
like that.
honest, yeah, I don't think EK can do that. I've tried as
Uh,
well. Yeah, so because when you export to a BOM or something, so I use that HTML BOM. I don't know if you what. So that's quite nice.
I
Yeah,
bomb.
IBOM. But then once you get the Excel spreadsheet, you're going to have to do it manually. So as many times
Yeah,
I send it to PCBWay and I have to say not placed, not placed, not placed.
exactly. I
So,
like most of the RF designs. Like I mostly do now RF designs, so they need DNP and antenna tuning and frequency tuning stuff. So I just had to like manually say like DNP or DNF,
yeah, it's exactly.
and
I've
see.
not found it yet, and I've been looking as well because I'm also trying to make different variants in different projects. Rather
Mm-hmm.
over place components for the same PCB than because sometimes you think ahead, but you just want to stay now in this mode.
Yeah.
But yeah, I've not found it, and I've been looking. I don't know if someone has made a plugin for it, but I could not
I
find
guess
it.
there was like, let me have you used there was one other key bomb.
No.
Key bomb, it had
So I
the
use
variant.
HTML.
Oh, okay,
Oh,
okay.
okay.
It
Do you
had a
understand?
variant thing, but it didn't actually created any variant file for it. So yeah, that
Maybe in
was.
version 6, because I know they're going to do a lot of new stuff in version 6 with rules and all that stuff. So, and
I am actually sending you a private chat. You can
yeah,
add it in comments. Like this was the one I used for CSV bombs. Uh, you can send it in comments. That this is the one I preferably use for sending to GLC PCB or PCBA.
okay.
Yeah.
Have you let JLPTB make your stuff yet or not? Because
So
they only do one layer, right? Population.
yes, only one layer.
Have you done it with them before? Because I'm trying to maybe send one of them.
I have used them in production actually, like
Okay.
for 30 to 50 PCBs, and
Oh, wow.
they actually have been like very good, very good.
Oh,
Yeah, like for my company work, I use the prototype services from them for around 10. First I'll do 10 batch populated thing. Then I do 30 PCBs populated. Then 30 PCB batch, and then I go with PCB bay if everything works fine.
Okay, because JL's a bit cheaper.
Yeah, but they don't actually do like
Two-sided.
two-sided production. So sometimes like, and they don't have any what say uh, testing services good. Like you cannot give any production firmware, so that they can test the PCB after they have assembled it for like mass production. PCB way can do it, and we used. Like,
so you've done it before, PCB way, where you've given them a test sheet or programming. And
yeah.
That's very cool.
Yeah, we the latest one we did like around 1,000 units, and they made a like they were obviously they it was a custom jig, and they charged us, but they can do it. Yeah.
So you do this as a professional engineer, I assume?
Yes.
Oh, okay, that's awesome.
Yeah. Like I've been doing this professional design for around 4 years, maybe. Yeah,
Oh, nice.
4.5 years.
We should have
And
a
I've been
Q&A one
using.
day. That'd be quite cool.
Sorry.
We should have a Q&A one day about the
Sure, man.
stuff. That'd be quite cool.
Sure. About high frequency, actually.
I'm no expert, but let's hear.
Yeah, no problem. Like in I was actually I wanted to ask, like, have you ever tried BLE antennas? Like there are specific antennas for every specific purposes. Like BLE can also do chip antennas. BLE can also do PCB trace antenna, or
just through the guys' Bluetooth, right?
Yeah, exactly. For beacons.
Yeah.
But what my understanding was, if you are using the like Bluetooth beacon, you should use a PCB trace antenna, not use ceramic chip antennas. But I don't understand why people actually force or say that you use PCB trace antenna rather than chip antenna. That was my question. If you had any experience or
chip, you mean a chip you just solder on it?
Yeah. You can, but that is more like reliable and more like PCB trace antenna is like PCB, like milling machine is actually tracing the antenna, and that can actually sometime maybe PCB sorry, the trace can be a bit fuzzy or something like that, and chip antenna is actual component which will be more good than trace. But I don't understand.
You sold it on pads though. It's like a normal IC.
Exactly.
Can it not be maybe that you are creating a capacitance that you can't control that easily? Like when you do your own PCB design, you can control some capacitance, some peanuts matching, things like that. I'm not sure. I'm just thinking what the reason can be.
Okay.
Because you have more control then. There's software, right? They can tell you exactly how the antenna should be. I know SMT is on their website. You can, with radio frequencies, you can tell them what you want, and they give you
yeah. Like they also in GLC PCB and the other PCB where they have a impedance calculator actually also, where you can tell them like, I need this material for my prepreg, like the dielectric material, and I need this inch of trace and this impedance calculator, everything. But I don't really know. I just wanted to ask this. No problem, man. No problem.
No, I'm just thinking, like, I don't know too much about radio frequency. I'm just thinking why they can tell you. So, do you have an example of the chip that you want to use as a antenna?
Yeah, actually, it was I was using at a point CC 2560, and there was it is actually a Zigbee. It can be used as Zigbee thread, mesh, or BLE. And at that point, I was not sure if I should use the chip antenna or the trace antenna, but we used the chip antenna.
And
One thing was,
did you
yeah,
try both and see the differences or not?
we actually used both for like 10 PCBs for chip antenna, 10 PCBs
Yeah.
for the trace antenna. And the thing I noticed was like, uh, the chip antenna was actually good, like good, compared to trace antenna in only one direction. Like, what I noticed was chip antenna is like omnidirectional, like, uh, like omnidirectional antenna. If you want to use frequencies or radio waves in one direction, you should use chip antennas. But if you want to use like a BLE beacon,
Yeah.
it is more good to have PCB trace antenna, because
Oh,
it
wow.
actually scatters the wave uh, in all directions.
So you use the CC2560, but that's the IC, right?
Yes, I see.
And the chip antenna, is that just generic?
I cannot actually disclose it.
No, it's fine. It's fine.
It's actually NDA, so I
Okay.
cannot close.
Speaking to that.
I can just tell that it was from Yagyo antennas,
Yeah.
and 2.4 to 2.5 gigahertz range.
Okay.
Yeah, I cannot actually disclose the exact
No,
part.
I understand. Especially if you're doing this for a living and stuff, of course not.
Yeah.
That's cool. So you use KiCad and Altium. Have you used Eagle before?
Yes. I used Eagle when I was like studying. I had the educational license.
Yeah.
I I didn't like it. Like, I don't like it, Eagle very much. If, you can I the major thing I didn't like was the cumbersome approach of making custom footprints and custom libraries for it.
Okay.
That is my personal preference. Yeah.
Yeah, but it still does the job. Okay. No, I was just wondering. I've
Yeah.
never used it before.
Yeah, it actually, uh, uh, like you can integrate it with the Fusion 360. It is like seamless integration, because Autodesk also owns EagleCAD and
Yeah.
Fusion 360. That is like seamless integration with the CAD models. But I do not mostly do the CAD designs, MCAD designs, so it wasn't actually meant for me. I still do a small CAD designs, like MCAD designs, which I do like from, I export the step models from KiCad or EagleCAD,
Yeah.
Altium, and integrate it with Fusion designs, Fusion 360. So it
That's
is
cool.
working fine for me. Yeah. One thing actually I noticed with the EagleCAD was, it is also like you have to pay for it, and for educational license or free licenses, you only get, I guess, 80 centimeter square board and only 2 years.
Okay. So, but
Yeah.
I think KiCad is quite amazing for being free. It's really,
Exactly. That is one, uh, like open source design, open source software, and has many good things, like impedance traces, and like the differential pair thing, and
yes.
layer
Yes.
matching, yeah,
And
meander and everything.
with your frequencies and stuff that you do, your layer stack, what do you normally choose?
I mostly use 4-layer, like,
But then do you
no,
have signal, ground, VCC signal, or
exactly, yes.
okay? So that's more the
Like,
generic.
yes, I tend to use 4-layer, but if like the uh, space doesn't actually doesn't actually allow me to do the routing or replacement, I go to for 6 layers, not
Okay.
more than that, because 8 layers is quite
That's-
expensive, very expensive.
yeah.
If
So and 6 layers with JL PCB way.
Yes,
Or?
yes, JLCP.
Oh, yes,
Like
okay.
every prototype or every POC we do is with JLC PCB, and then the mass production or more than 100 layers we do with PCB.
Yeah, I'm going to do 4-layer now with that macro keyboard because that USB differential was quite tough to get in.
Okay. Yeah. I had a question for micro keyboard thing. Which I know you are using F103, STM32 F103, but which exact number are you using?
It's a good question. I haven't actually looked at the components.
Like there are multiple variations of die and
You mean footprint-wise, or
yes, exactly, footprint. There is LQFP, UQFPN,
Yeah.
and the QFN 4832 and like that.
the 48, I think.
48. Okay. And for the programming, which environment would you use actually? I have used Embed OS. I am really
And the what?
Embed OS. Like
Oh, I've
it
never heard
is
of
really
that.
great. Embed OS is like operating system for 32-bit controllers. ARM 32-bit controllers, really great. But some people try to use HAL APIs, STM32 Cube IDE, or Zephyr OS.
Wow.
They have there are many free OSs.
Sure. No, I've never heard of these stuff before, so I'm not too
Okay.
careful with programs. And I know she does most with the Visual Studio and all the add-ons.
We can talk about it in the Discord. Yeah.
Well, that's quite, if you can give me a list of what's best to do, because I'm still
Sorry?
programming. If you give me a list of the programs, but it's only for STM, or is it the other ones as well, like at Mega and ESP32?
Okay, so for ESP32, my personal preference is ESP-IDF, and I have seen people using Arduino with ESP32, but my personal preference is ESP-IDF, their own integrated development framework. For
You program raw, eh? You don't use the Arduino IDE bootloader?
No. I use their IDF and Visual Studio. I don't use any of their any IDE. I just use Visual Studio.
So you just raw program.
Yeah, raw programming with for this ESP32 ESP-IDF. For STM32, I mostly use Embed OS. Mostly. I don't use other than that. Yeah. And for sorry,
you don't use Arduino bootloaders whatsoever. You just
no. Now as because Arduino is very compatible, very good for 8-bit controllers, and it limits around 32-bit controllers. So we use 32-bit with that. And for TI, MSP432 or this CC2640, 2650 or 2560, we use TI Simplink.
Oh wow!
I and my other
is it your own company or do you work for someone?
I work for someone. And
okay.
Yeah, I work for some corporation. So,
me too.
I also actually have made a proof of concept for my own small system hobbyist thing, and I am thinking of making a demographic launch for this only this community, then seeing how it goes. It is actually in electronic vehicles or in vehicles after 2014 year, there comes a OBD2 onboard diagnostic thing where you can actually get diagnostic trouble codes from engines and everything, and you get what is the issue in the engine or suspension or everything. I'm working on that stuff also.
Oh, nice.
As a hobby.
Wow. You never know how a hobby turns out, eh?
Yeah, exactly.
Oh, nice. That's awesome. Anything else? I think you know way more than I do, so you seem quite good up. Are you stream today? You said you're going to stream today, right?
I was trying. I was actually thinking of streaming today, but the internet here is not quite good at my locality. So might be tomorrow or maybe Thursday, because Monday and Thursday is my a bit chill day
Yeah.
from work. So
You're working from home now?
yes.
Okay.
It's actually like a curfew here in the locality.
Oh, were you from Kolkata?
No, I'm from Pakistan.
Pakistan? Oh, okay.
Yeah.
Sorry, man. Wow, I shouldn't mix that up, eh? With the
No,
Indian.
no problem, man. Like many of where I work, they also like mix up Pakistan and India, and
Yeah.
they think like I'm from India. And yeah,
Ah.
that's not an issue.
I know the rivalry for cricket, so I don't want to step on toes.
No, no. No. So,
Cool, man.
like anything from you or hello?
Yeah, sorry. There was some noise
I
there.
was asking if like I only had these two questions. Like,
Okay, no, that's fine then. Cool, man. Then, yeah, I'll probably do some routing. I don't see anyone else in the line to ask questions. So I'll carry on, and then if you have other stuff you want to talk about, just let me know. It's
Sure,
this program
sure,
is quite easy just to pop in, pop out. I think
yeah,
I'll
sure.
start today. Thanks a lot, eh?
Sure. No problem, man. No problem. It was quite good
Chat later.
talking to you.
Bye.
Quite good. Yeah. Bye, man.
Yeah, guys. So if you guys want to join the stream, maybe I should post the link here. So this program seems quite cool. I can just put people in and out. But if no one has questions, I'll just make a board today, I think. I must actually say what this link is for, otherwise people just come on. That works nicely, I think. Don't delete. I want to make a. What do I want to do? Share, stop sharing, share screen. Ah, come on, did I do it on the F drive again? So I know there were some questions about the layers and things like that. So maybe I should just show where to get it. So for this, I'm actually going to make a simple one as well. So yeah, this is not the it, but I already routed one with the 3 USB hubs and the 1 USB, but I actually want to make one that is simple, just a USB input, and then measure and be able to use the buttons. Because I think this could be quite expensive, so I want to make 2 variants. So one where we can, if you want to order it yourself, it's much cheaper than this one. I think this one will be quite expensive. So you can still have a micro keyboard without this extra functions. So we can start that. So that in Altium, if you push L, does it show up? Yes. There's all my layers. And earlier in the stream, we spoke about 4-layer boards. And then if you go tools, layer stack. Slow. And there you can see. So I've got a 2 top. So this is a 2-layer board. And then if I want to add it, I can add layers here. Insert layer below. So we can choose a plane or signal. So the difference is not, so plane will be like one solid plane, one solid copper, where it will just be, it breaks it nicely. So we can make it like ground or VCC, where a signal will be able to break it up in different copper pores, if you know what I'm trying to say. But it's not really that big difference. But then for 4-layer board, I would do it like this. I'll say ground. So you've got a FR4 solvers, and then let's save that. And then you see at the bottom here, extra layers got added, which is quite cool. In KiCad, I must just get used to jumping between the two programs. And then in KiCad, you can just go here, bottom, top left. And then you can actually choose your 4 layers, and KiCad will actually do for yourself. So there you can have power planes, and then I would do the same here, round. So this is just much easier. Like I said, if your signal's on top, if you make this mistake with your routing or something, to fix it is much easier than fixing it when it's inside the board. So yeah. I wonder if I really have to stop share, reshare. Strange. It's interesting. Cool, man. So I'm going to make this board now a simpler version. So I'm going to just remove the USB, add a USB-B. So I'll make both available to you guys, the one with the hub. So this is finished on my laptop, I just haven't got it. So actually a lot of differential routing here. It was messy, but that's not the issue now. You can also see it changed a bit now. So now if I go to my grounds, wherever ground is, that should be connected. Anyway. So let's get started. So I don't want this anymore. I'm just going to make a copy, guys, so you can save copy. I think you can export the group is the top here. That's a group, design work group. I've got this on my laptop, so it'll be fine. And I'll check it in on GitHub. So I don't want that. And then end of this week, I'm going to order both, I think, and then we can test it out. I do owe someone, one of the winners, one of these. I have not forgotten. So now I can see, yeah, so because I deleted the sheets, it's not part of this anymore. So only this is part of my project now. So I can just remove this. So guys, you're always welcome to join me. So if there's any questions, just say hello in the chat. You can click on the link. You'll be added at the bottom here on the waiting list. Pop you up, and then we can chat. You can share your screen, I think, as well. If you're busy with Altium, KiCad, even with Eagle, we can see what we can do. So now I'm just gonna design update. So hopefully it deletes everything. I'll just automatically do it. this pops up. I don't like rooms. Execute changes. And now they're all gone. So I can add a USB-B. Hey Rahul, you ready to join? Hopefully I can help you. Spaghetti Code asked me 2 difficult questions, so hopefully I can help someone. Just send a thumbs up or message when you're ready to be able to want to go on, because I can just click add to stream and you'll pop up. I want to add components. Yeah, sure, Ro. I'm going to put you on now. There we go. Hey,
Hi,
how are you doing?
I'm very good. How are you?
Good, thanks. I hope it's not difficult questions.
No, it's not difficult. It's like I've seen your posts recently, and just now I started following you also. You mainly you work on this PCB designing and sketching of this. For a basic beginner, what do you instruct to do first? How do we start from the scratch?
What is your aim? So what level are you currently? And yeah, what do you want to make? Do you
It's
want to
like
learn?
uh, basically, I'm an electronics student.
Yes, yes.
Yeah, but in our college and all, they don't teach us how to do this PCB designing and all those stuff. So if we want to get into this PCB designing field, if we want to take it as a career, how to start? Where do we want to have to start with this?
If you want to do a career and you're a student, I would start with Altium because it's free for students.
Okay.
Because most of the companies in the world will use either Altium, Eagle, Mental Graphics. I don't know a lot of people use KiCad, but if you want to just learn about PCB design, you can do KiCad as well. The principle still stays the same. But have you worked with something on a breadboard before? Have you built something like that?
Yeah, it's like not on PCBs, but I do some
No.
schematics.
Yeah,
Yeah,
but if you have a breadboard and you're building something, have you done that yet? Like build a small project?
yeah, I've done those things.
Yeah, so I would take a project you've already done on a breadboard and bring it over to a PCB, because then you already understand it and you're only learning about how to start with the program and how to use the program, because you already understand schematics because you've already
Yeah.
built a circuit and
Okay.
then routing of things.
So, and for this designing thing, what are the basic parameters one should know? What is the basic knowledge, minimum knowledge he should have? He or she should have this while using the PCB things.
So this is two different. So it's the PCB itself or the schematic, because it's two different ways of thinking. Schematic wise, you need to know electronic fundamentals, right? Like resistors, capacitors, things like that. Just understand it. But PCB design on its own is also a skill. So you want to have both, or which one?
No, for the PCBs, schematic things. Well, since I'm from electronic background, I can understand certain things. But for the PCB designing, what exactly should be known?
I'm going to open KiCad. Let me start with KiCad. Can you see the screen, right?
Yeah, sure. Yeah.
It's a good question, because I always say you just have to start, because you don't know what you don't know if you don't try. So I would download KiCad. Have you downloaded KiCad before, or Altium?
Yeah, I'm using Eagle actually.
It doesn't matter. It's the same.
Yeah.
Yeah, KiCad is quite. So you're going to start with a two-layer board, I assume. So I'm just trying to understand how to say this, because there's so much. So you need like component placing, routing, like how basic you want to go. So no 45, no 90-degree angles, things like that. If you know what I'm trying to say. Is this thing frozen now? Come on. Can you still hear me?
Yeah, I can hear you.
My screen just went not responding with a big arrow.
Oh.
So I'll chat until this thing pops back up, hopefully, because I don't know what happens when this closes. How to start as a beginner? I always
So
say
I
choose a
think there's some networking.
yeah.
Yeah, can you hear me now?
I can hear you. Yeah. Can you hear me?
Okay. Yeah, I can hear you.
Yeah. So I always say, so you know how to do schematic, right? So draw yourself a schematic of a circuit that you want to build. So I always like to have the end in sight. So have a goal to do a project, because if you're just I want to learn about differential routing, I want to learn about component placing, I find it quite boring. I like to have an idea of a project I want to do and work towards a project and learn what I need to do to get that project to work.
Okay.
Because that's how it is in real life. It's always project based. Any company is project based.
Yeah, that's true.
But so if you got an idea of a project, like what you're busy with on a breadboard, and then we can quickly run through something maybe. I can just show you how I would approach it.
Right now my camera is not working properly.
No, if you just give me an idea, I can open KiCad and we can go through it.
Yeah, it's okay. It's fine. Take any some simple schematics and simple of your own choice.
Okay, just give me 1 minute. I think I'm gonna have to just restart because it's still showing not responding, and I've got a feeling if I click away now, it's gonna say end task, and I'm gonna lose connection.
Yeah, sure. Take it.
So just be patient. I don't know how this is gonna end.
Definitely.
Oh, come on. I warned you guys this is gonna be it's a new software I'm trying. Ah, come on. Maybe I've got too many stuff open. There we go. Google Chrome is not responding. Close program. See you guys now in 2 minutes, hopefully.
Okay. Technical issues.
There we go. Something happened. Can you hear me now?
Yeah, I can hear you.
Great. Okay, cool. I'm back. Just reading some comments. Someone says the MPU 60 fell off with the IC controller. Can you tell me what HD circuit is on? That's a good question. Yeah, we'll get to that. That is more high power. Cool. What I can show? How cool is that? Nice. Sorry guys, new program. I'm getting excited about buttons. Let me just open something. File, new project. Just for example. Hey, Jay, I see you. I can hide this now. Cool. So yeah, interfacing MPU. So that's accelerometer. I wonder if I've got a schematic for that with any microcontroller. Okay, let's try that. Let's see what happens. Let's just wing it. Share screen. Cool. So in KiCad, you said use Eagle. I assume it's the same as schematic, right? So just place components BP. I might not have your MPU. Libraries. I wonder if I just use an example. Cool. You see this circuit? There's that MPU that they asked about. Mr. Rahul, you there?
Yeah.
Cool. So this was a drone that we tried to build, right? So we knew the drone had different components, needed the controller for the brains, how to program it, some power. We need some drivers for the motors to make it fly, and then the accelerometer. So this stuff you understand, right? Because you build on a breadboard.
Yeah.
Okay, so happy about that. So let me just, I'm gonna delete everything. Delete. No, man. I don't know if my computer might be struggling with all the stuff running. Oh, that's India today, cricket. My sharing screen or application? Let's share application. Let's try again. Yes, these circuits are available in data sheets. What is going on here, man? Let me close Altium. Oh, come on. I'll start closing all the windows, yes.
Yeah.
Struggling.
Exit Twitch and Discord. And try have not so many tabs.
Yeah, I'm closing all my Google tabs now. Close. Exit. Close. Come on, man. Need to buy a new PC? Close. While I'm waiting for this, how do you add a mesh grid on KiCad? What do you mean by mesh grid? I know how to change the grid to grid sizes and add a grid. What do you mean by mesh grid? Oh, come on, man. Murphy's Law. Let's try again on KiCad. How do you add a mesh grid on KiCad? What do you mean by mesh grid? I know how to change the grid to grid sizes and add a grid. What do you mean by? Let's try again. Will we get lucky? Cool. So KiCad is the same as Altium. When you want to highlight everything inside a box, it's left to right. And if you just go right to left, it's everything it touches. So it's just a quick tip. Okay. All right, you still there?
I'm here.
Cool. So we've got the schematic, which you understand.
Okay.
That's fine. Just trying to sort out this. Okay, cool. So that works. So we spoke about this, and this you understand, right? So schematic's not your problem. The PCB's what you would like to know.
No, schematic's not a problem. Now, okay. How do you convert the schematic into a PCB design?
So in all PCB programs, there's always a link between your PCB and your schematic. So the most important part is your schematic, because that is your go-to thing. Because if there's a mistake in your schematic, your PCB will think it's normal, and that mistake will carry on through. So your schematic is probably one of the most important parts. So in all PCB designs, you will always just update from your schematic to the PCB. So in KiCad and Altium. I'm not too sure about Eagle, I assume it's the same. So once you update it, and it doesn't break. Oh, come on, man. This is going very well. Yeah, it doesn't show on the stream, but like it's not responding again. What more must I cancel? Discord, close. Close. Why are you struggling so much? I wonder if it's because I'm streaming it. So let's just try get these components on the board. Then I'll share my screen. I'm going to try a simpler project because I don't know what the hell is going on here. Battery charger. No, I don't think it's KiCad. This never happened before when you streamed. So I don't know if it's Google, the Chrome with this new program. I actually don't know. That's a bit irritating me now, but it's fine. It is what it is. Maybe it just doesn't like me. But I'll do it easier, less components. Okay, there, that's a better start. That is a better start. Maybe if I share my entire screen instead of application, let's try. Cool, so I chose a different project now.
Okay.
So we've got this battery charging circuit that we did. So it's got V-bus, V-bait, ground. Just another thing, when you're making PCB design, it's always nice to make use of ports. So you see on the left-hand side, here's ports. And this is like off-sheet connectors. So you can make a sheet that you can use for any project in the future, if you understand what I'm trying to say. So it's like programming local and global variables. But we can get to that. So we've got this. And like I said, you always go tools, update. So you always take from your schematic to your PCB. Please work. There we go. And then it'll tell you what it's going to add. So it'll add the capacitors. And you've got this. Where's my USB? It's not there. We'll add it. So once you've got the components, the bigger it gets, I always first look at my schematic, even at the components. Can I do this? So this is how I go through it. So I can see C1 as V-bus ground, and it has to be close to my IC because of decoupling capacitor. Because what can happen in PCB design is that V-bus and ground net name is the same throughout the whole PCB. So it does not know that Was it me? Anyway, it does not know that this capacitor needs to be close to this IC. You understand what I'm trying to say? And just tell me if I'm going too fast or anything.
Hello.
Hello?
There's a bit of lag over here. So
Sorry?
no, there's a bit of lag over here. I'm sorry, internet issues over here.
What's the last you've heard?
Just a minute, I'll get back to.
So any questions on the side here? It's quite cool that I click on it. What do you mean about new grid? Mesh grids? Mesh grids are used in touch switch for proper grounding. So you're not talking about the grid of the PCB. You're talking about grids as in on the PCB physically, not the dots that you see. So you can also get a grid here. How do you add a mesh grid? That's a good question. Let me just see. So in KiCad, you could, in KiCad, I know I could do an Altium. I lost the screen now. So let's just click on the question again. A touch switch. What touch switch are you using? Like a capacitive touch? Because I just did that without a mesh grid. So mesh grid, let's just be sure. It's where I know KiCad. KiCad. I'm getting confused. In Altium, you can make the holes inside easily because it's a grid rate. Rule. I'll have to come back to you. I know how to do an Altium. I don't know how to do in KiCad. I don't know, maybe just delete that. What happens if you do this? So you can add fault zones. We make the top, I always make a power. Yeah, you should be able to do it. You can do a thermal release, chamfer fillets. Rahul, I'm going to add you on now. I should not go to 3D. That will even kill the computer more. Let's just put a B bus here and see what happens. Just repour. Don't know why it's being so weird. Some thermal relief. There must be something here. I'll have to play around with it. I know how to do in KiCad. In Altium. Stop saying KiCad. I'm not too sure in Altium. That's it. Hey, you there?
Yeah, hello.
Hey.
Yeah, I'm really sorry. It's raining outside and I have some internet issues over here.
That's no problem, man. Yeah, so I always look at my schematic while doing the PCB.
Okay.
Because your PCB does not know that this C1 for decoupling capacitor must be close to this IC. So your decoupling capacitors must always be close to the IC, right? You understand that? Yeah. So it only sees V bus and V ground. So if any other IC uses V bus, V ground, it will not know that you want C1 with this IC. So always keep your schematic and PCB close to each other. And then I just work left to right normally. So this is my main focus. And then you should try to put it in such a way that you have to root as little as possible. So you always want to keep your traces as short as possible. R is for rotate.
Okay.
Yeah, I'm just trying to think about, but it's going to be just through doing it quite often where you learn more. You're learning by doing. So a nice thing is with most programs, once you click on it, it will show you on the right-hand side that it's highlighted.
Okay.
So I can know my LED, this resistor 2K is the speed of which, or not the speed, it controls the current of how you charge your battery. So you can see these white lines called RAS nets, and they will show you where it's supposed to be connected. So it's always nice just to keep it in a certain way. So it's quite close. I route there, and I'm done. So D1 goes there. So R is for rotates. In Altium it's spacebar, so I'll still keep space. So you just place. At the beginning, just keep it as short as possible. Keep friends together. There's a decoupling capacitor, so we want it nice and close to ground and V bus. There's another decoupling capacitor on the output. So this is a very simple example, but it's just to get started. A VBAT ground. Okay, cool. And now these white lines are basically how you're going to route it. So in KiCad, you just push this button, retracts, and it will literally show you how to route it. So for me, I always have copper pores on my board. So that is over here. If I throw a copper pore, so copper pore is literally what it is. It's copper that you just put on the whole front of the PCB. So this is just general terms you can start to understand while doing PCB design. And this is common for all PCB designs. Come on. Just say if I'm going too fast or anything, just stop me, ask questions. So otherwise, I think you've been kicked off.
No, I'm listening to. I'm just watching all this.
Sorry?
I'm listening and I'm just observing things.
Okay, no, that's fine. So you can see when I put a copper pore on, you can see it actually connects to the ones that it's already. So when I double click on it, my properties, you can push E for properties, and then I put my top copper to my V bus. So I always, when I have a two-layer board, I always put my voltage on top and my ground at the bottom. It makes routing much easier, and it just keeps your ground shorter because then it's just better design. Let's try for so I do that. So this is the basics. I will start most of my designs like this.
Okay.
There's some good questions popping up there, I see, about soldering. So now, so a PCB, it might be called 4 layers, 6 layers, 12 layers, but it only has 2 sides, right? It only has a top and bottom. They haven't been able to put components, or they might actually have, but it's not for us, put components inside the PCB, but that's not going to happen for us. So the red is on your top, and the green is at the bottom. So I just put a layer of copper at the bottom of my PCB. So for me to get to that place, it's a thing I need to use called vias. So I add a via. So this via is like a special portal that just goes straight down to the board and connects the bottom to the top. So my bottom side is ground now, if you understand what I'm trying to say.
Yeah,
so
I mean,
I can push, place the track.
Yeah, Mr. Plumput, I have a doubt over here now.
Mm-hmm.
In my college,
you can call me JP, Yeah.
Yeah, in my college, during my engineering days, we had this VLSI designing and using this cadence software.
Yeah.
While doing that, when we were placing the components, these connections over here, what you have done from this ground to, these are quite in a linear path, but they had instructed us that these lines, these connections should be always in the straight. They shouldn't bend over because they would have some misconnections. Oh,
Yes.
so in this PCB, doesn't it come into picture? Doesn't it be counted over here now?
Yes, no, that is, you're talking about not having a 90-degree bend in your tracks. So
Yeah.
I've not put any tracks in this now.
Okay.
This is a copper pour. I understand what you mean. It's actually a very good question, but you can see it's not 90 degrees. It is kind of bended there, you see?
Yeah.
And over there it's 90, but at the end we put a thing called teardrops. So
Okay.
teardrop actually, don't know if I have it. Will this work? Anyway, but it's a good question because if you use Altium or other designs, in KiCad can do it as well. And then you'll see it actually connects it in a way like this. Can you see the screen? So
Yeah.
it makes it like this, so it's not 90 degrees.
Okay.
So there it's not 90 degrees, which is right. There it is also not 90 degrees, but it's not. The 90-degree rule was done because back in the day with etching technology, it used to catch the acid traps. So they improved manufacturing a lot. So it doesn't happen that much, but high-speed frequencies and stuff, then yeah, it's not good practice. So always keep your tracks 45 degrees. So it's true what you said, what you were taught.
Okay.
But we use a thing called teardrops. I'm going to try and get it working now.
Sure.
So yeah. So if we just do this with vias, but yeah, please just ask questions like that. So I can push V and a via will come up. And
Okay.
now you can see the special portal down to the bottom. Now you can see the red is still there, so we can just go, come on, full all zones. Oh shucks, no, not that button, unfull all zones. I need to report. You always need to report in KiCad. Well, there should be like a, just what I do, when we do design, we'll check and it reports it. What have you done? I can run this by push. V for via. So also, once you do a lot of PCB design, it's very nice to know the shortcuts on the keyboard. It makes it quite fast, things like that. Where's the repo, guys? Repo. So if it do design rule check, it does automatically. What is going on here? Just press B. There we go. No. Yes, you're right. So what happened? Thanks, Jay. So what happened is I'm on my bottom layer and my whole bottom is ground. So if I go to the top, you can see the copper got disconnected from this pad now because it's only part of ground, so it's not part of the top. So yeah, I want to, then let's start routing so I can get to your point about, thanks, Jay. So when you route, you always want to keep it not 90 degrees, like you said. At the left-hand side, you can hide your copper pores because it sometimes gets irritating. It's still connected, but it's just, I'll answer your question now, Yitch. So you can see, yes, I haven't used KiCad D. So D is to move it. So you can see I always shoot 45-degree angles, like you said. That's that's very true what you said. So there's nothing wrong with that. But I wonder if I can, let's create, that's fine. I want to create not a short, but let's do this. That goes, you can go underneath components. So this is a pretty easy board. So like this, as long as there's no 90-degree angles, all is good. Like this, you don't want this, so that is bad. It's as easy as that. So the V bus. So you can see that if we place now, just put a bar here. You can see that's VBUS. It's not connected to anything, but it has no white line on it. That's because of the copper pole. So the copper pole connects it.
Okay.
I just want to show you with teardrops. Just want to create an ugly one. Okay, this is bad, but let's just do it like this. So you don't normally want to do this as well. So you don't normally want to come out. So if you go teardrops, did that work? No way. Useless plugin. But then normally chamfers it, so there's no 90-degree angles. But really, if it's slow signals, 90-degree angles is not the end of the world. Under 90 degrees is not good, but like this is 90 degrees, right? So it's not that bad. Is there, any other questions? Like, it's difficult to tell you how to start. I will just start, and then if you ever have questions, let us know, and we can help you. So the important thing is to make sure your schematics are correct, because that's the most important part you have. Because the PCB only knows what you put on schematic. It does not know anything else, if that makes sense. So your connections can be wrong and shorted and everything, but your PC will be like, well, I'm according to your schematic. So that's important. And then have a look at your schematic, what components are close to each other. Is there any specific rules that, I don't want to go too fast, but like differential pairs, which signals are differential pairs, which is a bit higher voltage, higher current. So your track widths is important. Your track clearances, so that is more for power. I don't want to get too much into that now, especially if you haven't started yet. And no less than 90-degree angles, like you already know.
Okay.
And then keep your traces as short as possible. Just get making, man. Just make things.
Yeah, sure.
Once you start struggling, you'll learn a lot. I'm just thinking what I struggled with at the beginning of PCB design. Are you on our Discord channel?
Sorry?
Are you on our Discord channel?
Yeah, I'm on the Discord channel.
Okay, great, man. So you can just ask questions there.
Sure.
Any other questions?
So like PCBs, they do this multiple layers. Now you are done a 2-layer PCB.
Yes.
You go for this 3 layers, 6 layers. Actually, what's the requirement for going to that most layer parts actually?
There's 4 layers, not 3 layers. So
4, 6.
Yeah, 4, 6, 8, 12, 16, until like 60. Well, one reason is component density. So if you've got a lot of components next to each other, then it's just easier to have signals in different layers. Also with EMC, EMI, it is much better for interference if you have a ground plane and a VCC plane inside. So it's for I would say for EMC is the biggest thing. But yeah, as a hobby, it's not always necessary. But yeah, it's component density and EMI, EMC. That's the only reason you go for it. It's more expensive though, just be aware of that. It is. But what's the reason you want to go to 4? Have you gone to 4 yet? Have you made a PCB before or not?
No, I haven't.
Okay.
I tried doing those things, but I couldn't get some basic knowledge of this. PCB, now I'm just studying actually.
Oh, okay. Okay, so you must use Eagle or whatever and make a PCB. So choose a project
Sure.
that's interesting for you. So whatever hobbies you have, try to make a project around that hobby. That's quite cool to make something that you like, right? Because then, so I'm enjoying LEDs at the moment, so I'm making a lot of stuff with LEDs. Yeah, just start, and if you ever have questions. So if you start, I think I'm going to do this more often now on Sundays. I don't know, this might be better than just me streaming what I make. So if you start on something, then you can share your screen. I can help you through it and stuff. It's easier to help when you have a specific problem than just general how to make a PCB. So I don't know, on YouTube, we've got a video how to take an idea to PCB. I don't know if you've seen that.
Yeah, I saw it. I saw those things actually.
Okay, yeah. So Kerry made a video about she had a project on a breadboard and she took it to KiCad and how to order it, all that stuff. So yes, is that good enough for you at the moment, or anything else?
Yeah, that's it. Thank you.
That's
So
all.
I got this basic knowledge. Once I start doing things, when I get doubt, I'll come back to them.
Yes, yeah, just start. So draw the schematic, because things will pop up that you just don't know about or think about or something like that. But yeah, so schematics, draw a schematic on a schematic sheet, and then see what happens. But just shout if you need help.
Thank you very much.
Cool, man. Cheers. Jay, you ready? I'm just trying to. So yeah, so you're talking about capacitor touch. We actually made it in our coaster capacitor touch now but we left the copper at the bottom. There was no pore. We didn't hatch it, and it seemed to be fine. Hey Jay, I'm just going to go through some questions here on the side, and then I'll be with you. Can you hear me? Everything fine?
Yep. Okay.
Oh, cool, man. If components are too close, won't it be an issue when soldering? Good question. It depends on your level of soldering and if they're going to populate it. So normally you have a board outline to tell you to stop. But yes, the closer it is, the harder sometimes it is. But that's why you also place the components close to where it's supposed to be. So in this example, if I have this close and this short, it's not the end of the world. It has to be shorted. But that's why you see this white outline is sometimes they just stop it. It's called mechanical outline. But yes, the closer it is. But if you have a hot air gun, it's quite easier, much easier. But if they populate at PCB wire or something, you can have it pretty close. That should not be an issue. Then get how the copper pore works. Yes, so the copper pore is you literally put the whole top with copper. But once you make a track, the system will automatically remove the copper close by. So the red is one copper, it's connected to something, but you can see it's only supposed to connect to VBus. I made it connect to VBus, and nothing else is connected to it. So it automatically makes sure that's not shorted. Does that make sense? So if I go to the bottom, I only have one thing, and it's all ground, so it's greens. But if I go, for some strange reason, I want to go connect this, add a wire, go to the bottom, come back up, and connect this. Take the long walk. You can see that it straight away disconnects from the top, and if I go to the bottom, it disconnected. So the system will make sure that it's not shorted. The need is just, it's much easier to route. So if I go to the top, so I have ground here. So for me to get all my ground here, it's a long distance where I can just go straight to the portal at the bottom. It's also just about, with EMC and frequencies and stuff, you don't want cuts in your ground plane. So if I start doing this, I start cutting my copper pores and things like that. And this is, you don't want islands like this. It's nice to have a nice copper pore, things like that. I hope that's easier, but it also just helps with routing. So if I've got a busy board, if I can have my ground, I just connect down my V buses. It helps a lot with routing when your board gets a bit more complicated. It's so cool that I can click on it. Anyway. Jay, how can I help you? Sorry,
Yeah,
I
hi, Captain.
Krish said hi. Krish. Yes.
So, as I heard, as Rahul was talking about creating a PCB and then bringing that, creating a schematic and then bringing that down to your PCB, and you were giving this. My question is pretty simple for a beginner, any beginner. So, as you said, go through the basic, go through all the components, your resistors, your capacitors, and all this. You should be well aware of it. But there is another aspect of something that is data sheet, right? So as I can see on the schematic, there is a picture right above the process. Yes. So that's a reference picture that has been given in the schematic by the component manufacturer.
That's a very
So
good
my
point,
question
yes.
is regarding this. How do you bring the reference and utilize it in your schematic while doing a schematic? Because the intended purpose of that component that you are referring to might not be the way that the reference is showing. So you may not actually be doing.
Yeah, I'm listening.
Yeah, so you may not actually be using the component as it is shown in the reference. You might be, connecting something else to it, but that is just there to show that you could do it this way. For example, let's say we are using LM306, an amplifier, and it has a channel or a mono channel, and then you can cascade it and do the rest of the things. So we are using that, and we have a reference.
LM what?
LM306.
Yeah. Okay. I just like to see the example.
Yeah, so if you see the reference, it's does it have a reference?
This is just the op amp. What is
Okay. Wait, I'll give you another one. Where did that one go?
Because you kind of have to use the you have to use the chip to do what it has to do, right? You can't make it do something it can't do. But I understand what
No.
I understand what you're trying to say.
That's not my question. What I'm trying to say is, whenever you see a reference, right, it's just there for reference.
Yes.
It's not the solution to your problem. So how do you incorporate the reference to your solution?
You first need to. So I can use this as an example. So this is just a reference.
Yes, exactly.
So you need to understand why this 2K capacitor, 2K ohm is there. So what is the purpose of this? So you need to understand the chip. So if I go to this data sheet, you can't. It's a very good point.
Is understanding a component, understanding a PCB layout and routing, that's a good point. But understanding the data sheet is another aspect.
Yeah,
it's
another,
left behind.
It's another skill. So
exactly.
So this resistor here, 2K, you're going to have to read the data sheet. So this is actually just speed of how fast you can charge it. So I can change this 2K. So this 2K is the fastest I can charge is 500 milliamps, I think. But if I change it to 4K or something, then it will be a bit slower. And then, yeah. Just thinking how I can say this. Status. F is your. That's the status if the LED is charged or not. So you need to understand this as well, that the status is, will pull it low when this battery is fully charged. So it's quite a smart chip. Jay, all I can say is you have to read the data sheet and try to understand it. There we go, fast charge, milliamps. So you can see there, if I put a 10K, I'll charge at 100 milliamps. 2K, I'll charge at 500 milliamps. But you will never use the circuit in a the IC in such a way that it doesn't connect what the pin's supposed to connect, right? Or am I misunderstanding you? My output is still my output, but the capacitors and the resistors on the side might different. But
Yes, exactly.
Or do you have an example
that is what I'm
of where it's totally different?
No. That is what I'm saying. So, as you said, right? My question, let me rephrase it. What I'm trying to ask is the skills for a PCB designer or for a designer, the skill set of doing a schematic, the skill set of routing or bringing your schematic into PCB and then routing, the importance of these things are and reading the data sheet. Is it all equal, or you can just ignore data sheet and or
You
you
can't
have to
ignore data
pay
sheet. No.
exactly? So what amount of importance do you have to give to data sheet? Because
A
that's
lot.
the main point from where the complete what do you say, how to use the component or where to use it, what are its limitations and everything comes up, right?
Yeah.
So to what extent, or again, this data sheet, if I can see, it's roughly around 28 pages. So where do you screen through, what do you go through, like what are the important points that you have to pick up from a data sheet?
Well, firstly, you have to be able to charge your battery. That's important. That's a very good question, Jay. So the data sheet is very important, but it's important from your schematic stage already. So
Exactly.
but how to read it, everyone is each to their own. So I will go through the feature one straight away, see open drain. But this is where you need to know a bit more technical stuff about what open drain is.
So yeah, again, coming back to the same question, is for a beginner, what amount of technical stuff should he or she be knowing so that they could at least understand something from the datasheet? Because if you give this to a first year or a second year student from BTech, they may not understand it as much as a person who's recently entered into the field or in the final years of their BE,
It's a very good question. Yeah. So how much should you be able to understand to start?
Exactly.
I think your first page of the data sheet should be enough.
Okay, the first page of data sheet should be enough,
Yeah,
because again, when we this is just a charging circuit, but when we go through some more complex things like a controller or an ARM-based controller, a microcontroller, all these things, they have a different parameters. And again, from the point of view of coding it, yes, you should know the data sheet, but how much is it impacting even while you're making the schematic or the PCB in the first place? Because coding and creating a PCB go hand in hand.
Yeah, but it's different skills. So let's just also important thing is the Enrata. How do you say it? I'm just going to go through the STM just to, for example.
Yeah.
And this errata sheet is also very important. So errata sheet is where all the errors and faults will be.
Yeah, another question is regarding that when you go to the manufacturer's site, there are multiple documents that you can refer to. So you have to go through every single document, or just the data sheet is enough?
I would go through the data sheet and the errata. So the errata is normally sheets that they realize there were some mistakes and they keep workaround and they tell you, okay, don't do it this way, set it up this way. Yeah. But then, like if you look at the STM, you can already see the package that you want to use. You'll be able to see the timers. All the stuff on the first page is pretty much the information you need. And then you can just scroll down. If I'm a total beginner, so I don't
yes, exactly.
So I would just look, okay, yeah, it looks fine. My voltage is 3.3 volts, so I can use it. I know I use 16 megahertz crystals for my Arduino, so that's fine. I can debug. Do I need timers? So I assume you know a bit, and then I will start look, okay, is there any help with schematic, anything? So there they've got the pins already, and then pinout. This is also important. Somewhere should be a pinout map, which is this.
So from the pinout and the schematic, from the schematic point of view, the data sheet again gives us the data for creating footprints. So my next question is on footprints.
Yeah. Okay.
So when you create a footprint, right, be it in Altium or be it in KiCad, Eagle, or anywhere, so what are the important factors that you should look into the data sheet, or what are the information that you're hunting from your data sheet to get a proper footprint?
So this is a generic size, so it's universal, right? So this will be the same. So KiCad, Altium should have this type of thing, but it can also be for if you're going to hand solder it or put in the oven. So if you want to hand solder, it's also always quite nice to make the pads a bit longer or bigger so you can get solder on it. And the gap in between, you just need to make sure that your manufacturer can handle this gap, the solder mask opening. But this is quite generic. So
again, the manufacturing part comes in is again playing a major role into the PCB designing itself. So can I say that while creating a project, if it is something that you are sure about, taking it to the final, like getting it printed and everything, so what are the parameters that you can keep in mind that you can just
okay, like that. Important things for manufacturers are your center point. So the center point you give on your component is where they're going to pick it up on the machine. So that's very important. So if once you make the component and your center point's not in center, they've got a nozzle that picks it up and will place it wrong. But that's only for SMT. If you do it at home, it's not an issue. Make sure that your mechanical outside, like we had a question earlier about if my components are too close. So make sure you give yourself some space that you think is good enough for you to hand solder or SMT solder. So it's not only this footprint, it's also the mechanical outline, things like that. And then there's a discussion about solder mask opening in between. So when I'm talking about production now, not at home.
Yes.
Production, they squeegee like solder mask over the pads. So if the solder mask openings there, they can be short sometimes, if you know what I mean. So it's always nice to maybe have solder mask in the middle to make sure it doesn't short. But that's about it. And if you can just keep to this. So the recommended footprint on data sheet is it's accurate. I've had not an issue yet. And make sure you label your pin 1. That is important. I've not labeled my pin 1 sometimes, and you have to look at it. It's not good. So if you understand what I mean, so on the dot on top.
Yes, I understand.
Yeah. Besides that, it's pretty much proper solder mask opening. So solder mask opening is just where they take away the solder, guys, the mask on top of the PCB. So if you look at this, so that's solder mask opening. So sometimes people will make this a bit bigger so you can hand solder it easier. But sometimes also they keep this open. Another thing I'm thinking about it, when you get to, how can I say this? Components that are a bit closer to one another than this, it is sometimes better to place your components. I'm talking about production now, when they want to do it in production.
Yes.
At home, it doesn't matter. To place it like, come on. Place it like this. Because they will squeegee from the top to the bottom. And so if you think about it, my solder paste will go from top to the bottom. So the chances of shorting in between is very small. If you understand what I'm trying to say.
Okay. Yes, I understand.
If I have it like this, the chances are small, but it's possible. And I have it like this, there's a possibility that I've take my solder paste and I've put it onto the pins. So it's always just good practice to have it like this.
So what you're trying to say is, so it's a good practice to keep your components vertical rather than placing it horizontal or in some other form factor, because when they are putting the layer of the solder mask
Paste, yeah.
layer,
Paste.
the solder paste. So the solder paste, the green or the color of whichever color that you choose, right?
Yes. No,
So it's not gonna
no.
short out.
I'm talking about the paste, not the mask. So they've got a.
No, the solder mask is the white outline or the border
green.
or your writing.
No, that
Okay.
is silkscreen.
That's
so
silkscreen.
Silkscreen is your writing, called your
Yes,
overlay.
that's silkscreen. Yes,
And then your solder mask is the covering of the copper. So they have a machine where, have you seen a what do you call it, stencil before?
Yes, I have seen a stencil
A
before.
metal sheet. So they'll have it in the machine,
Yes,
and they'll
yes.
take a massive squeegee and just squeeze the solder paste. Hey, Patrick. So yeah, so I like to have my ICs as well, actually at 45 degrees and not 90 degrees, because it just looks cooler.
Okay.
So that's also possible. So you don't have to be old school and stuff. You can actually do this. There's nothing, it looks weird, but it's nothing totally wrong with it.
So from the manufacturer's point of view, even if you give this, it's not a big nightmare for them, right?
No.
Even if the components are on a very small scale.
Technology has gotten so good, especially us. This is not, for them, it's not close. So if you open your phone and your computer, the way they compacted all those components, we're doing peanut stuff for them.
Exactly.
We think it's difficult for them.
For that comparison, we can say the Starlink's receiver, that is a big, massive, almost around a meter long disk, which is completely a PCB. So technology has gone too far.
And there's ball grid arrays, things like that. So we really don't have to be too worried that they won't be able to manufacture our boards.
No, but then the question was again the same, that when you, let's say when we are going through JLB PCB, when we are trying to print, so what are the parameters that we have to see on their side so that we can do our routing, our layout and everything according to that?
I'll show you now. Where usually are ordering a PCB. You ask, Patrick, you're asking where do we normally order it? I normally order it from this company, PCBWay, or PCB. So these are the only two that I use. What? Yeah, so these two. So this is quite for, it's a bit cheaper, but they're better with population. So if I want a board made that they populate, I use PCBWay. And somewhere here you can see the capabilities. So every single manufacturer has capabilities.
Yes. So how do we incorporate this in our, yes?
Yeah, I'm actually busy with a video with that. It's a good question, because you can see, so this is where your rules come into play in your design. KiCad rule-wise is not that good in my opinion, because it's very limited. So let's say minimum drill is 0.2. So if I go, does this work? If I go here, and then I can say drill, you can see my default is 0.4. So I will not be allowed to make a, I will not be allowed to make a drill that's less than 0.4. So you need to make sure that your rules for your PCB set up in such a way that they can manufacture it.
Yeah, so that was again a question. So what kind of rules do you have to look out when you are actually giving it to a manufacturer?
Track width, clearances, drill holes, bias, also your components distance from the side of the PCB, because they cut it, right? And so there's some tolerance there.
The key part distance.
So they might cut a bit skew or something might happen. But they actually have, if you go PCB way Altium, they actually have a file you can download that you can just import into your Altium and then use it. That's somewhere. I need to check it. It was a JLPCB. One of them had it. Because what you can also do is, if I've got rules, I can share my rules with you and you can import it. So when you work at a company, everyone uses the same rules.
Yes, exactly.
So does that answer it?
Yes, it does.
So that's the most important is your rules. So schematic, check the rules. Let's see what Patrick asks. Question about solder mask and solder paste. Are you talking about? So this is the green part is solder mask, and this opening is solder mask opening. But the paste is actually where you tell the manufacturer where you want the stencil size. You understand, or am I understanding you correctly? So do you want to know what is the size of the paste that needs to be put on with respect to your mask? Maybe I should open Altium. It's much easier to show. I think a good rule of thumb is, it depends also on your thickness of your stencil, because you can have your stencil different thicknesses to have more paste on it. So what happens is you put the paste on, but when you put the component on, it pushes the paste, so you don't want it to. So rule of thumb is normally about 80%, but it's just, so let's just have a look what we've got here. So guys, if you don't want to understand, so if I've got I need to learn how to say it properly. I've got my mask opening, and this purple part is where I'm saying the manufacturer, I don't want any solder mask on there. So solder mask is that green thing. So I actually want to expose the copper so I can solder onto it. But then I've got another thing that's only used when you order a stencil. It's called solder paste. So you can see the solder paste is a bit smaller than the mask opening, because when you put it on, it squishes out a bit when you paste it. So I normally make it 80% of the pad. I wonder if I can open KiCad Altium. That's a good question. I haven't focused on paste in a long time because I normally solder everything at home. Krish, are you still there? I see you in line, but you're not connected. Let's just do this again. So that's the copper. Top solder.
Captain?
Yes.
I have another question that's coming from Shubham Mohan, the one that you read about capacitive touch. His question is that if you have seen a capacitive touch as a module in itself, we find it having a different grid. It could be a circular rings, or it could be just a zigzag pattern. So how do you implement that in your PCB, and how do you create it or make it?
Yeah, so KiCad, I'm not sure, I'll show you now in Altium. Where's my solder mask opening? Cool. So you can see there as well. So I must actually show you guys how to make the component. Because the pink there is your solder mask opening, and then the silver there is the paste. So the paste is always a bit smaller than the paste is always a bit smaller than the solder mask opening. Just want to see. No 0.1. Yeah, Patrick, I can't give you a value. I normally have it between 80% of the size of my pad, but it might just be preference. So you can see 0.12 from the sides. Have you made something at the manufacturer for that you're asking this? Because this will only be used when you have a stencil. It's a very good question, though. Jay. I should actually have a look at what the rule of thumb is. So it also depends, because once they have, there's a machine that pick and place and they push it on. So the force they push it on, LEDs have, each component needs different type of solder paste sometimes. I won't pick it equal. You can, it's not the end of the world, but that means just when you put on the component, there might be a little bit that goes off the pad, because your component will push the solder paste a bit out. Chris, I'll be with you now. I'm just going to answer Jay, then I'll bring you on. Chris, you can chat in normal chat, eh? I see there's a private chat inside here. Let's just see if I can sort you guys out. Do I have a couple more? Place polygon. So I think there might be two different ways of doing this, a long way and a short way. So you know how to do a copper pull, right?
Yes.
So let's see what happens.
No, but the question is
the grid.
No. It's not the grid actually. It's okay. Have you? Can you open an image of an capacitive touch, or an?
I think I know what you mean. It's got a hatch thing at the back, right?
Not a hatch thing.
It's a copper pull with holes in it.
It's
I know.
circular ring. It's kind of an antenna, but not an antenna in a proper way.
I used it because with the coasters we made, we've got touch sensors on top. No, I have to go switch to a different language in my head. Sensor. I just know this website has it. So talking about this, right?
Yes, exactly.
This doesn't have the copper at all.
Yeah, that's a the one at the bottom. If you can just scroll down, that has a cell screen right there. Yes, that one.
So you're saying this is all copper, circle copper?
Yes, it's kind of a strange of it's exactly like routing, but then it's not like routing. It's spiral. Yeah, in Altium it is very easy to do this. So you just have to just say what kind of
it's your questions for KiCad then?
Yes, exactly. Because again, Shubham does not have an access to Altium, so
I'll have to investigate. I honestly don't know in KiCad. I don't know if it's possible in KiCad. There might be a plugin.
Okay.
I will do some research and get back to you.
Yep, sure.
Please don't call me Mr. Plumpot. It's JP.
Captain.
So on LinkedIn, no, not you. It's for Patrick. It's just JP Potgieter. But yeah, that's cool. Jay, I'm going to put Krish on quickly, okay?
Yeah.
Thanks, Dave.
Thank you so much.
Pleasure. Thanks for the questions. Krish, you're on the air.
Yeah, hi.
Hey.
I mean, I really don't have questions. I was just there listening to the questions. It was actually kind of fun, to be honest.
Okay.
I mean, seeing the professional stuff going on.
Yeah,
I'm still in high school.
yeah, it's a good time to learn, eh? Imagine you learn this stuff now and when you go to university or college.
Yeah,
That's
exactly.
fun, right?
Yeah. I mean, I can add this in the activities which I did in the college application itself.
Yes, but what projects you busy with?
I mean, I was doing the drone, but
Yes, yes.
due to like study reasons and stuff, I paused it. And right now, I'm kind of busy with this robot which I'm building. So it will basically do is that it will. You know about golf, right?
Yeah, I love golf.
Yeah, have you play that, man?
Yes.
Yeah, so in the driving range, like there are balls that are kept at the far end. So what I'm trying to design is a robot for that to pick those balls. But before picking them, it will try to make or plan a route so that
Yeah.
the balls that the bot collects are more in number, and due to that path, the efficiency of the robot will increase because the effort that robot applies decreases due to the correct path. So I'm trying to do this project with this graduate. uh, so let's see how that goes. I mean, I think it can come until next year, like full-fledged
Yes.
machine. So I'm busy with that. I mean, I have done some designs on paper, not on like some CAD
Yes, that's
software,
fine.
and I'm participating in this competition. So you compete while you learn. So we are
Oh,
do so we what we are doing is like we are simulating robots. So in this lockdown period, as we are all in, we
yes.
can't like physically go and participate. So what they have done is given the access to these softwares, and we can simulate robots
Oh,
in the
nice.
environment. So
Well,
we write
how do
some
you
Python.
simulate it? Do you use drag and drop icons, or do you program it, or how do you simulate it?
I mean, I can share my screen and show.
Yeah, if it's possible. I'm not sure how this program works.
Uh,
I'm going to
uh,
stop share. And what happens if you try to share?
uh, okay. Can you see my screen?
No. Do you use share screen at the bottom? I'm not too sure how it looks for you guys.
Can you see it now?
I can add it. There we go. That's pretty cool.
So yeah. So this is the thing. So this is all Python
Oh, okay.
going on right now, and this is actually a robot called ePuck. So
Okay.
puck is something like it is used in ice hockey, like that small black colored disc. So the robot is here, and I can control it using my keyboard. So uh, it moves forward and then left, sorry, right, and then forward
Yeah.
again. And I mean, we are still in task 0, so there are like 8 tasks over like 6 weekends. So we have to submit it on Thursdays, every Thursday. So we have just started.
Oh, nice.
So we will be learning through this portal. So like videos, documentation, and other stuff like that will come later on. So that
So
is
what's
what
the
I've
program
done.
called?
It is WebBots. This one. WebBot.
Webbots. That'd be
Yeah.
nice because that is very cool. And then there's so then the code you do yourself.
Yeah, I mean they gave some sort of code before the start, and I did some tweaks to make it more efficient.
Okay,
So they will be giving some more code and some more tasks to do later on.
that's
So I
awesome,
mean,
man.
yeah.
That's
So
very
that's
nice.
my
I'm going
yeah,
to download it because we're helping the kids in South Africa, the younger ones, and that might be actually quite
yeah,
cool for them to play around with. Thanks a lot. Web
yeah.
parts.
I mean, it's open source and it's for free. I was thinking that they will give some sort of access to this, but I've figured this software from them. I mean, that was cool.
Okay, cool, man. Great. I see we got Kalyan on the line as well. Any more questions, Krish?
No, not exactly. I
You
mean, I
sure?
can leave.
No, no, you can ask anything you want. You can always come back. But you must download
Huh.
KiCad and start with the drone, man.
Nahin, I have installed KiCad. Like I'm working on Linux right now, so I
Okay.
left Windows. So KiCad on Linux is actually very fast, and like it does not give problems that Windows give.
Okay. Let's try that.
So you can dual boot or maybe single boot as you wish.
I don't know. I've never tried Linux like that before. So always scared I
Ah,
lose my stuff.
no, you can always first try it using VMware. So that
Okay.
is a
Dual
virtual
boot.
machine. No, not like you will be downloading something called this VMware. So there is this software, and then you can run Linux on Windows
Okay.
virtually.
Wow. Let's try that. Cool, man. I'm going to speak to Kalyan now and see how it goes.
Okay.
Everything good?
Hmm.
Hey, how's it
Hey,
going?
hi, how are
Hey,
you?
good on you.
So, history about any circuits or any previous times, olden circuits which developed into modern uh, softwares, like analog circuits converted into softwares. Any ideas like that?
Sorry, just repeat that. I'm not understanding fully. So old circuits.
Say we have libraries for 555 timers and all now,
Yeah.
inbuilt libraries. So
Yes.
any full-fledged built circuits like timers,
Yeah.
fully automated timers or alarms, many alarms, totally converted into a software library individually. Are there any circuits like that?
Oh, that's a good question. You're talking about, so you want to create a 555 timer, for example, and just have it on the Arduino IDE, for example. So you don't literally have a 555 timer, but you have it in the software. Is that what you mean?
Yeah, exactly. Yes.
I don't know. Never thought about that. Is there anyone out there who actually knows about it? 555. Is there a specific circuit that you're wondering, or just general?
I found a very old book my dad owned. It's about alarms. So
Yes.
I'm trying to try all the circuits in this. Whale whoops, siren, and simple alarm. Full circuit
But it's all
with the
analog, probably.
components. Sorry?
It's probably all analog.
Yeah. Any analog circuits converted into libraries to access directly from LT Spice or anything like that.
Oh, that's different though. Altium is simulation, right? It's not for programming or anything.
Oh, okay. So
Yeah,
we
I've
can
used
use that,
Altium
right?
before. Sorry?
Yeah.
Yeah,
My
Altium
course
you can,
had
you can
me.
use.
I had a course which only focused on LT Spice.
Oh, nice.
So yeah.
I actually don't know. So you want already made libraries for old designs?
Yeah.
I don't know. Is there anyone out there who knows? I've never had to. I'll have to Google, man. So you want to build some alarms?
No. I'm just trying those circuits. I'm just asking any other ideas about those old circuits.
So you want a whole circuit into one chip, one. Don't know. Schematic wise, yeah, but I'll have to Google. I really don't know. I've never tried to play with that before.
Okay.
Anything else? Sorry,
For
man.
now, that's it.
That's a very good question. I'm trying to think now. So you've got, what's that book about? So it's about just different old circuits.
Yeah, this book was written by MC Sharma. So he made only alarms. This was an introduction DIY book for anybody starting to do electronics, hobbyist
wow.
electronics. It's a wonderful book. Came across one back.
NE 555. I don't know. Yeah, it's about, yeah, okay. Yeah, I don't know. But what's the reason you would want to do it and not just take the independent components?
I'm just trying to find any if there are any libraries individually made for these old circuits. I would like to simulate them or keep them in my computer.
So your library is not a coding library. It is for LT-Spice or simulation
Yeah.
library.
LT Spice and if possible KiCad also. Hoping for that.
KiCad, yeah. So okay, let me just backtrack here. So you would like it for simulation, but also like footprint and component.
Yes.
Okay. So yeah, so that is possible footprint wise, yes. So footprint you can use like snap DDA. So if you have an example of a component or not?
Components. Let's see. An individual component or the circuit name?
Yeah, so the circuit, you can give a circuit name. The circuit would be a bit difficult because the circuit, yeah, we can try. Because the 555 timer is a chip, it's not a circuit.
Yeah. So there won't be libraries available for the whole circuit, huh?
Sorry? No. There might be
Okay.
for the components, but for a full circuit, sub-circuit, what is sub-circuit? So here's something that Patrick shared. Let me just share it with you.
Okay.
So there's a website called Subcircuits, and they've got like, it seems like a lot of black boxes.
Okay.
Where you can have stuff, I'm not too sure. But I use this for my footprint sometimes. So if you have an NE 555 timer, then you'll have the footprint and stuff. But that's just for the component.
Got it. Okay.
But you are more concerned about, let's say, you want a whole circuit.
Yeah. Let's
as
say
one.
this is the circuit, entire library coded for this like that.
Yeah, so I don't know if you're going to find that on the internet. So
Okay.
in KiCad and Altium, you can make function blocks.
Okay.
So for this example, I put the LEDs like this, and I'll make it into a sheet like this. So this sheet is like kind of what you want, right? So this sheet has all the LEDs, all the components, all everything.
Okay.
So I can make this a component in my library for Altium and KiCad, and then when I can go, so I make this a component, this whole sheet, and I put it into my next project. I don't have to redraw everything in the sheet. So I think you're looking for something like that.
Okay.
If I'm understanding you correctly, yeah.
Yeah. Okay. So how do we do that in KiCad? If that's possible, you can.
I will go have a look now. Good luck with your exam, Hardik. So it's pretty much the same. So in KiCad, you have to create things called ports.
Yes.
So I've got VBus, VBAT, and this is a way for the outside world to know about the sheet. And then I can go to my file news. Come on. File new schematic. I'm confused between the two programs now. I need a new schematic. Oh yeah. No. Do I have to put can't just make a new schematic? I'm getting crazy.
You want to start a new schematic?
So I want two schematics in one project. I've done it, but then do I need to paste a new one? That is very strange. I'm just going to put a new schematic. I find it quite strange. So I've created a new sheet in the folder where it is. So here you can see I just made a sheet.
Okay.
And then it appears here. But it's quite strange that I can't add file new. I must be going crazy. Anyway. So if you go here on the side here, you can play sheet. Like that. So, I saw you on the wrong screen. There, then I can create a sheet here.
Okay.
I am winging it now. Okay. So it's a bit different than Altium. Good point, Patrick. So in this, let's just change it and remove this. So if we go back to our battery, we need to create a sheet here on the side here.
Okay.
And I can create a sheet. I'm going to call this, that's my file name sheet, battery.
Okay.
And now if I go into it, I actually made a video about this and I forgot about it. And then somewhere I need to go back. There's my back button. So I can exit.
Down.
No, not that exit. I need to jump back to the sheet.
Okay.
Save. So we've got this. Anyway. I need to go watch my own video now. There, right click, leave sheet.
Okay. So you'll go to the old one. Okay, fine.
Yes.
All right.
So I can
So
take
if you
this.
double click on the open square, then you'll enter to the.
I'm going to take this and paste it here, just so we have it.
Okay.
And then we can go back here at the bottom as well. Alt back.
Okay.
And now we can actually put some pins here. Right. There you can see VBus appears, VBAT, ground.
Okay.
So you have the right here. Hey, Saeed, I can see your question. I don't know when the stream's going to end. I'm just winging it. If there's questions, I'll answer it. So what we actually create here is a kind of thing that you would like. So we created the sheet that contains all the components inside that sheet.
Okay.
So then we can create, and you can actually, I must actually double check with KiCad. Altium, you can say this is a component. So if I start a new project, I can take this and put it in like a function block, and I will never have to redraw the circuit ever again. I can give it to people.
You just need to bring the function block, then it's just, you can continue with the circuit.
Yes, so if so inside here is this components, and these three here tells me this is going to the outside world. So my VBus is my input, and that goes, my VBus, my charging, my VBAT is my output, and my ground is input. That makes sense. Okay. So this is, I'm gonna make this smaller now. Resize. No, it doesn't matter. So if I have another sheet here, I can, okay, let's take this slow. Another way to do it is if I place a sheet again, and I want to place a voltage regulator. Come on. And I go in it. I can go a pen schematic.
Okay.
So now I can go to a place that I've had a schematic before. My drone might have it. Trying to look for a battery charger. There we go. So I've got a SMTM cherry. So now I want a microcontroller.
Okay.
So I've just added a circuit I drew about 2 months ago.
Okay.
But because I made use of ports, I don't have to redraw this. I just appended it, and now I can go back to my sheet, and then I can add my pins. Wrong button. There. And you can see all the pins come out.
Yes.
You understand how this works?
Yes.
So this is like global variables. So this is on the outside world.
Yeah, 3 by 3. Okay.
Yes. So this circuit I can make once, and I never have to use it again.
Okay, got it.
Yeah.
Yeah, that basically answers all of my questions.
That's great.
The one I had.
That's very good. Yeah, but if you get stuck, just ask. Yeah, we try to help where we can. I'm just thinking about other things. So it just makes it easier, because if you have to keep redrawing a microcontroller you use many times,
yes,
it gets frustrating. So I've got the sheet. So I actually got on GitHub and Discord, I think I've given all the sheets and stuff, so you can use it.
Yeah. Okay.
I think so. I'll share the link again.
Okay.
I think so.
Thank you.
Cool, man. Is that it?
Yeah. That's all.
Cool, man. Have a great day.
Yeah, you too.
Yeah, Patrick, that's good points. I enjoy using sheets because then I can just keep using it. I don't have to redraw it. I know when you have a big project, it's difficult to keep everything in one sheet. Saeed, you still there? Cool. I think this program works quite well. It's nice chatting to you guys. Any more questions? I think I'll do this more often. I think quite a nice way to help you guys one-on-one. If you guys aren't part of our Discord yet, you guys are welcome to join. I'll share the link. If you join it, just remember to put thumbs up in the rules, otherwise you can't chat. That's our Discord link. Any more questions? Otherwise, I'll call it a day, I think. Make some tutorials, go eat some food, maybe come back later tonight, who knows. Let me know, guys, what we can work on, what we can improve. I'm enjoying this program quite nicely. It works quite nicely. Maybe I'll buy it and then we can use Twitch and YouTube. But everything that I think it worked out all right. I'm losing the plot here. Guys, I'll see you guys then next week. So next week we are going to do a live Q&A session with a friend of mine called Bob Vermeulen. So Bob works for a company called Balvi, where they build flying cars. So Bob is a young engineer that we're going to ask him some questions. How it is like to, after studies, how it is, what is needed to become an engineer in the real world, because I think a lot of people just want to know what next. So that's going to start next week. I also lined up some cars, mechatronics people, some mechanical people. So we're going to try to really get the engineering world talking to you guys. It'd be good to make some schematic and layout reviews. You mean, okay. That's a very cool idea. So high frequency, why did they do this? What could they improve on? What they did well? That's a very cool idea. Like going through a chess game. I'll definitely work on that. Thanks, Patrick. That is very cool. Any other questions, guys? Speak now, or you have to wait until maybe next week Sunday. Or maybe later tonight, I don't know, see how I feel. Pop in. Make RF. Yeah, I don't know if I want to go to RF yet. I'm trying to help the people who's never done PCBs before. So it's a catch-22. I don't want to go to, but I guess we can do both, right? And it's also a learning thing for me for RF, because I don't use RF that much. I should. Thanks, Patrick. Thanks for popping by. I appreciate it, man. Where are you from, if I'm asking? Yeah, sure. Send me messages, DM me. Should play some music as well. Boop, 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 boop. Power distribution networks. Yeah, send me some messages and we can make some plans. Guys, if you just joined, is there any questions? Poland, nice. I'm not too far from you. I'm in the Netherlands. I see we've got some people who just joined. If they've got questions, I'll wait a bit. I like how I can show Eric Bokaten. Wow. So this is Eric Bokaten. Nice. Yeah, you must also look at Lee Ritchie. So he's also very good with the stuff. I can't spell, but it's fine. Google help us. Cool. Patrick, you must join our Discord if you're not on Discord yet, and then we can chat there as well. Everyone can learn and stuff. Cool, guys. Just I need a haircut. He has a lot of good things. I'll copy it and paste it in Discord. No worries, man. Mosquito. Cool. Any questions, guys? Any more questions? Thanks for joining, Patrick. Thanks for helping as well. It's nice to interact like this. It's very cool. And I think a lot of people can learn, and even I can learn a lot. I still have lots to learn. Guys, any more questions? Then, 7 people. Any more questions? Maybe I should. So next week we're gonna, like I said, I'm gonna speak to Bob from Milan, a PCB engineer, firmware engineer. He's working on building a flying car with his company, or company he works for. So next week we're gonna interview him. I'll like this, allow you guys to ask questions. I'll ask him some questions, what I think that you guys already sent me on DMs and things like that. And yeah, so I'm going to do it more often now. So I think once a month at least, I'll have an engineer on the stream just to answer some questions. So I already have a mechatronics guy lined up, mechanical, some software people. So a lot of people in the high-tech industry will have a chat with you guys. I think it'll be quite fun because I think a lot of you guys just want some advice about the real world, not always technical, because some of you guys are way more technical than I am. Okay, guys, I think that's it. If there's any questions, you better raise it now. Like, shout at me, tell me to stop. I've got a private message. Who's that? Cool, man. So, and let me know, guys, on Discord and Instagram, what do you guys think about this way? Is it better where I just go back into just doing my projects and chatting to you guys, or must we keep this interactive going? I enjoy this. I feel like I can make a better difference like this than just do my own thing, because everyone has their own problems and hopefully I can help it. But like I said, I'm not an expert in everything. So there's people on the side that can help as well. Like, it's just community. Cool, guys. Until next time. Yeah. Bye.